So I'm back with a follow-up video to my Vernier scale video, and I wanted to break this out into its own video so that the other one wouldn't get too long. But I wanted to go over the number one mistake that new people and even experienced people make with a Vernier scale sometimes, and that has to do with reading the OD micrometer. So if hopefully you've already watched the video where I talk about how to read the Vernier scale on a micrometer. And the number one problem, number one mistake people make is when it comes to counting those lines. So I have an example here. Let's try and get this to zoom in. Move a couple of things out of the way. So I have an example here. Let's try to take a reading of this. Very quickly, I see 1.2, I see one line, and then I see the 24, and which one lines up? I actually haven't looked at this beforehand, so let's say the 4 lines up. So let us write that down. So I have my first reading, I get 1.2494. Okay, this is my first reading. I'm adding 25 thousandths and the 24 thousandths to get to 49, and then I added the 4/10ths on the scale here. Okay, so what's the mistake that people make? What I just showed you is the correct reading, and I was a little bit careful to hold the mic in a certain way that I can only count one line. But if I rotate this around, it's going to be hard to show on the camera, but there's a second line there. And sometimes what people do is they make the mistake of counting that second line and including that second line in the calculation I just did. So what people, the steps I explained were, add what you can see easily, 1.2, count the lines. Well, in this case, people say, yeah, I can see a second line right here on the thimble, right at the edge. So that's 1.250. Then they add 24 thousandths to get to 1.274. And then they add the thimble scale, and the reading they end up with is 1.2744, which is completely wrong. Okay, so the difference is they added that line when they shouldn't have because they could see it. So I want to talk about why that happens and how to avoid it. For beginners, it's a completely understandable mistake to make, but it's also one that can be avoided. So first of all, let's talk about why it happens. Is there something wrong with the micrometer? No, there's nothing wrong with the micrometer. It actually comes down to the manufacturer when they're marking this with a laser. They're setting the increments. They have to pick a thickness for the line that you can see. It really comes down to how thick are these lines, because if they're so thick that you see them really well, they're not useful because they're so thick, they overlap, they don't give you any precision. And if they're too thin, they're hard to see, and they may be hard to manufacture that thin repeatedly. So they have an increment that's a compromise that you can see well. You can still use the you can still use the micrometer as intended. The downside of that is sometimes the lines are so thick, they start to peak out when you get close to the thimble and you get close to that rotation. So a lot of beginners, they're just going through the motions. They're not double checking themselves. They're not thinking about, does this make sense? I'm adding the second line and then I'm adding 24 to that when they should really be only adding one line and like most of the second line, but you haven't quite gotten there yet. So the way to avoid it, the way to make sure you don't make a mistake, what I do, it comes down to the thimble. Come on, camera, zoom in. There we go. It comes down to the thimble. Have you reached the 0 or not? When you reach the 0, you've gotten to the second line. So in this example, I'm working way up from 20 to 21 to 24, and then it stops. I haven't gotten to the 0 yet, so I'm not going to add that line. But when I just sneak past the 0 to, maybe just less than 1, I have gotten past 0. I'm going to add that second line, and then I'm going to only add that tiny piece that I moved beyond the second line. So right here. Again, please check out the direct camera feed if it's not looking so good there. I'm really doing my best with the lighting and the zoom, but it's a little hard to control. So in this case, I have moved past the line. I will add 2 lines in my calculation, and then it's just a tiny little addition. And in this case, when I move back, I'm only going to add 1 line. Then I'm going to add 24 thousandths, which is most of the way to the second line, and then whatever tenth I get with the Vernier scale. So that is my strategy. I still use it whenever I'm close to the line. It's not something that goes away with experience, because you really got to be careful when you're doing this math. And I still make mistakes occasionally. The OD micrometer itself, I would say, is not as big of a risk. If you've watched the videos about micrometers and hole inspection tools, I did point out, and I even have an example of when you're working with a hole mic and you're calibrating this. When you the way to calibrate a hole mic is you're going to loosen this sleeve and then rotate it to match your calibration 0. Which is pretty much the same as an OD mic, except there's nothing to loosen. You're just grabbing onto the sleeve and physically moving it. But because this one has a free floating sleeve, it not only rotates back and forth, it moves back and forth in the axial direction, which is going to affect how clearly you see some lines, right? Because when I calibrate it, I might float it so that I see, this much of the line. But when somebody else calibrates it, they might see a more of the line. So because I have it here, I have the calibration ring right here. Let's, all I was missing was my screwdriver. So let's calibrate this on 1 inch, and then I'll try to demonstrate exactly what I'm talking about in this video, as well as the hole inspection video. So when I check 0, yeah, I'm a little bit off. I really haven't checked the calibration lately, so I'm a tiny bit off. So when I go to calibrate it, I'm gonna loosen this sleeve, and I have some control this way. See, I'm measuring a 1 inch ring, and I can see that line. But how much I can see that line, I have control. So if I set it, I can just barely see the line. Some people are going to set it so you can see the full line. Some people are going to go a little bit too far, probably. And okay, I've definitely gone too far. They're going to hide the second line, but then they're going to leave it, at whatever angle they feel is right. I know it's really hard to see on the big monitor there. So I'm going to set it. I like to set it where I can just barely see the line. That's my style. And I'm going to lock it down, and I need to loosen it and redo it. So I need to keep doing this. I'll give it one more shot on this video, and then we'll wrap things up. If I don't get it right this time, we'll just move on. But I might as well show you how to calibrate this while we're at it. So I don't normally do this standing up, trying to do this in front of a camera, so bear with me. It can be a little bit challenging to hold everything. All right, not too bad. I'm still a little bit off, right? It's using the Vernier scale, I'm probably a little bit small. I haven't quite gotten to the 0 yet, so I'm probably 1/10 small. This ring itself is stated to be about 40 millionths smaller than 1 inch. So I'm actually pretty close. I'm not going to keep fighting it. But what I want you guys to take away from this is just remember, whatever scale you're using, have you gotten to the 0? Have you gotten to the 0 or not? It matters how much, whether you add that line, you can see or not, because sometimes you will see it, but you haven't reached it yet. So thank you for checking out this video. Thank you for checking out my other videos, and please visit my website for more training videos, more resources, and thank you, and I look forward to seeing you for the next one.